Spot Mini. This four-legged robot can move in such a way that its head remains in the same position. The weight of the robot is almost 55 pounds. The module with the head, which is actually a mechanical hand, adds to the weight of the robot another 10 pounds. The developers say that the robot's capable of running on the built-in batteries for about an hour and a half, depending on the type of tasks performed. To orientate the robot uses a series of sensors that scan the world around, cameras that calculate the distance, and a gyroscope. It's worth noting that Spot Mini is a fully electric robot. It doesn't have any kind of hydraulic mechanisms, and all the joints are moved with the help of conductors. CHEETAH Robot. The CHEETAH robot has the technology to run like a true cheetah. Among other things, this robot can change the position of its back to increase the length of its steps and speed up. The CHEETAH robot was tested on a treadmill. The power source was a hydraulic pump. Also used were devices that help the robot maintain balance. Currently, the CHEETAH robot is not ready to compete against a real cheetah, which can reach up to 70 miles per hour. However, the engineers hope to achieve that one day, to match the real prototype. For now, the robot's capable of travelling at 18 miles per hour. Scorpion HEXAPOD Robot. This terrifying robot looks like a real scorpion and was developed by 3 students from the University of Ghent in Belgium. They used the most modern technologies to create this robot. The modules for the legs and the tail, for example, were printed on a 3D printer. The frame of the construction consists of 2 plastic 6mm wide plates. Inside the frame there are pipes for the cables, while resistant special latches hold together the different parts of the construction. The robot can move in all directions, overcome obstacles, grab objects with its tweezers, and even attack using its tail like a real scorpion. To find the obstacles, the robot uses infrared sensors and a frontal camera. To achieve an even more prodigious resemblance, the tail of this mechanical animal leaves a red ink mark when attacking. It's not poisonous for humans, but will let you see the way the creature attacks. MIRO. This small mechanical fish can carry out research work at a depth of 165 feet, but it's also a great tourist attraction thanks to its bright look, its LED lights, and its incredible and very real movements. Each of these fish has 2 motors and 4 infrared distance sensors, thanks to which the device can overcome any obstacle. This water robot can be controlled in first person using glasses and a controller. AIRACUDA. The company Festo, famous in the world for its robotic animals, has presented their new son, the robot fish AIRACUDA. In addition to fins motors, which allows copying the exact movements of a real fish, the device has liquid muscles, a creation patented by the company itself. These muscles have elastic hoses made of rubber as well as aramid fiber. Using compressed air, the mechanical muscles move in the same way normal muscle tissues move, stretching or contracting as needed. 2 muscles are enough to begin the movement of the rear flap of the fish robot, while 2 other muscles are responsible for the control, allowing great maneuverability even in deep waters. Like a real fish, inside this robot there is a swimming bladder, a special cavity that allows regulating the compressed air and setting the fish in motion. To use this mechanical fish for 30 minutes, you need 400 litres of compressed air. AQUAJELLY. Here we have an autonomous artificial jellyfish with an electric propulsion system and an intelligent mechanical system which can adapt to any external changes. A transparent hemisphere and 8 tentacles with LED lights make up the bionic jellyfish. Inside we can find a central motor, 2 lithium-ion batteries, a navigation block and 2 servo motors to control the movement. The robot's able to calculate the power supply, and when the battery's running out of power, the device automatically sends the information to the charging base located on the surface and swims to it on its own. To communicate on the surface, the mechanical jellyfish uses a radio band, and when being underwater, it uses a system of infrared lights with a working distance of about 3 feet. That way, when receiving the signal from another robot in the vicinity, the jellyfish can perform an evasive maneuver. In addition to the environment sensors, the robot has internal sensors to control the energy level and pressure, thus calculating the immersion depth with high accuracy. EELUME. This robotic snake, developed by the Norwegian Institute of Science and Technology, has been specially created to work underwater. Its mission is to perform observation and repairing works of oil facilities, as well as recording videos underwater and investigating sunken ships. A cable is currently used to interact with the robot, but in future it will be able to swim autonomously and perform underwater research without an external signal. The elastic electronic construction of the underwater device allows its use in complicated places, which cannot be reached other than using other special equipment. That way, the bionic snake is a cheap and practical solution to perform technical tasks of low difficulty. This robot can help perform inspections, illuminate dark areas, clean underwater constructions, and screw nuts and valves. ROBOCRAB. The creators of this unusual robot were inspired by the Ziphosaura, one of the oldest animal species on planet Earth. The device moves using a set of small legs, pushing itself away on the surface, and is able to return to its initial position using its movable tail, in case the robot turned on its belly. Like the animal prototype, this mechanical crab is not afraid of water and can move easily in shallow water. Aqua penguin. Like a real penguin, aqua penguins have an aerodynamic shape, perfect to save energy. The force of movement of its wings allows them to maneuver independently in narrow areas. Aqua penguins can find their way in a body of water and move independently. With the aid of a 3D sonar that mimics that of the real penguins, they can communicate with the world around them and with other bionic penguins. A completely new feature in the world of robotics is the torso of the penguins, which can move in any direction. With quick and accurate regulation, aqua penguins can swim in groups without crashing, controlling depth, pressure, temperature, and stability. Flying bionic bird. Unlike other more common and popular drones which use a special propeller system for flight, this small device is capable of flying with the help of its own wings. When the robot's in the air, even other birds may think it's a real bird. This is possible thanks to the appearance of the device. The dark grey aerodynamic chassis has been decorated with a beak and a pair of eyes. The wings can also flap 18 times per second, and the tail is used to control the flight. In addition, the body of the bird robot is made of elastic synthetic foam, resistant to scratches, attacks by other animals, and possible hits during forced landings. The wings of the robot are made of carbon fiber, a durable but very light material, ideal for all kinds of maneuvers in the air. The total weight of the device is 9.2 grams, while a special and ultra-light battery weighs only 1.6 grams. A special decorative egg allows you to charge the bird. The drone is controlled with the help of a free mobile application, available for iOS and Android. There are 2 control modes according to the user experience, Simple and Expert. The control radius of the device is 330 feet, and a battery charge guarantees 6 minutes of work at maximum speed, or 7.5 minutes at normal speed, while the decorative egg allows between an hour and 75 minutes of charging. PLEUROBOT. The company BioRob, which works in the creation of new generation bionic robots, has presented a robotic lizard, whose behavior resembles that of a salamander. To faithfully reproduce the particularities of the movement of these lizards, the developers used X-ray images. This allowed them to accurately recreate all the details of the animal. Like true lizards, which have great mobility, their mechanical analogues can also move through difficult terrain and even swim. A waterproof skin allows the device to remain for a long time in the water, which is why this bionic animal can be used for search and rescue. The construction of the robot allows controlling each active joint separately, whereas a model of neural networks responds for the control of the robot. The structure simulates the nervous system of some parts of the brain of a real salamander. This approach allows the robot to accurately copy the studied movements, in addition to performing complicated tasks which go beyond the possibilities of a real salamander. According to the developers, they hope to continue with their creations, and probably in the near future will show us a robotic dinosaur. Bionic Kangaroo. The Bionic Kangaroo project until recently had been kept secret, but recently the company Festo has shown the public its robot, which mimics the jumping of a kangaroo, including its most complex mechanism, using the power of one jump to perform the next one. The Bionic Kangaroo uses this principle with the aid of springs that recover the mechanical energy of the landing and release it when making the next jump. The robot is 3.2 feet tall and weighs 15 pounds. In addition, it's capable of jumping 2.6 feet horizontally and 1.3 vertically.